collection space for a number of years. And in fact, some of the things of the software that I've been involved with involve specifically risk assessment, risk management within the petroleum industry. This talk, Risky Business, is an outside-in look at agility and risk management. Is a collaborative effort with my partner in crime, Chris Matz. Chris is London-based, and he works in the financial downtown area as a business analyst, project manager, and works specifically with the financial risk side. And we've gotten together at a number of conferences and started comparing notes and said, well, there's a lot of different ways of managing risks that are out there. And we're exposed to those risk management tools from the outside world, but we're also within the software world. Let's take a look at what other people do in the industry in terms of managing risk, managing risky businesses, and help people understand risk, help people understand how to manage risk a little bit better, and what some of the tools agility brings to make risk management even more effective. So the first thing we're going to do is play a little game. So what I'd like to do, we're a little bit scattered out, what I'd like to do is get teams together that are about, looks like we can get about 5 to 6 people at a table. That would be good. So if we could coalesce here a little bit.
Come on, guys. Come on, guys. Cool.
Everyone now fights over. I'm not. So we'll just do this quickly, form into some teams, and I'd like you to pick a name for your team, and when you've got that name, just shout it out, and I'll write up your team name. So, anyone got a team name? Any team names? Canucks. What's that? Hub? 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 What's that? What do we got? Names? What do you got? The names of the team? A1. A1, all right. Some more names? Vancouver. Vancouver, all right. All right, who else we got?
We're the A team.
The A team. We have A1 and we got the A team. Oh, is that the A team? Huh? Did I spell that wrong?
No, you're good.
I got it right, okay. And even more? One more?
Sunny side.
The sunny side, okay. All right, is there any team that didn't give me a name? Right, okay. The next thing I'd like you to do is a couple things. There's a bunch of materials up here, so I'd like somebody to come up and pick. But one thing that we'd like to do is distribute some of these. Probably have to split those up a little bit. And we can also come, we can get this one first, and then we can come up and get whatever. We can start complete task B first. So just those 4 items on this piece of paper. And here's the team names. You got the Canucks, the Hub, A1 Vancouver, the A team, and the Sunnyside. So your name, your team name, the team can complete task A first, and the team can complete task B first. Yeah, each one per each person write this. All right, and when you've got that, collect them, and I'll collect them in some place, and I'll be walking by to pick them up as we get started on the next crazy thing.
Can you explain the task A and task B started?
Well, task A and task B. What?
You're a management, aren't you?
Yeah. Task A and task B. I mean, this is.
Well, literally ambiguous.
Yeah. Not so cleverly. All right. Everybody pretty much done with that? You got your thing? You ready to get moving here? All right. Get those collected in the center. Or in one place so that I can come pick them up. And we'll get started then. All right? Ready to go? Here we go with Task A. Here's Task A. Task A. Create a 6-sided random number generator, something like a dice-like thingy. Every member of the team needs to roll a double 6. And when you're done with that, whenever member of the team rolls a double 6, raise your hand or shout it out. Shout out, we're done. So, if you need more. Oh, well, maybe, yeah. Choice L. If the A team, and you chose the A team and the A team. Or at least you supported your own team. That's good. In fact, we got a couple people at the A team that supported their own team. That's a good sign of team unity. But unfortunately, you were wrong on both accounts. We got Mark from the Canucks. He at least supported his own team. Canucks, but wrong again. Let's see, we got Ranford from the Sunnyside team. Chose Hub, not too bad, pretty good. Not your own team, but you said, okay, these guys look pretty strong, I think I'm going to go with them. And then Sunnyside, you supported your own team on the second one because you didn't even know Anonymous was in the game, because they're a stealth group that came in and disrupted everything at the end. All right. Why didn't you choose your own team to start with? My card says Task A Hub and Task B Anonymous. You know? How'd I do that?
You just wrote it.
I'm not stupid. I waited until I knew the answer, right? But we do this all the time in software. We do it all the time in risk. We make predictions without really understanding anything, without knowing the context of where we're at. We get silly requirements that are totally out, without real context. And we go off and we do things we don't understand. That's not the best way to run a risky business, right? In your risky business, there's things you try to do. You try to understand and manage and bound the risk and understand and manage how you can leverage that risk. Because risky business, the good thing about risky businesses is risk generate a lot of revenue opportunity, real opportunities for business. So I'm going to do a little bit of a roundabout thing of how risky businesses work. Of course, we know, we just discovered, it's tough to make predictions, especially about the future. This quote is so nebulous, we don't even know if it was Yost. It's really challenging because they're unknown. They're huge, and they have huge risk associated with them, huge downside, because if you get hit by a hurricane, this was the Weather Service predictions of about the 18 different weather services predicting what Hurricane Rita was going to do. And Hurricane Rita was one of the largest at the time, the Category 5, which was the highest category hurricane when it was about the point that these predictions made. And just about a month earlier or so, Hurricane Katrina had just made severe damage to the New Orleans area, which is right in here. Now, what do we know about every single one of these predictions?
They're wrong.
They're wrong, right? The collective information is useful, but each individual item is wrong. The only thing we know for sure is what we can measure. We can measure the point where the hurricane is. But everything else, the banding of it is useful. The banding tells us something that, well, if I'm I can be pretty safe if I'm in New Orleans. Okay, unfortunately, if I was in I just relocated to Houston because Katrina just wiped me out. But so now I do have to worry because Houston's around here. And the center of that mass is headed for Houston, which could have been a very disastrous impact. As it turned out, we got spared because the hurricane went just to the east side, and the east side is the nice side to be on, is the dry side. So Houston had a little bit of trouble from Rita. But the thing about hurricanes is that they work unpredictably, but we can understand by managing that uncertainty, we can make some useful generalizations and work from it. In fact, this is a report that I pulled out of the Houston Chronicle showing how much better we've gotten at understanding hurricanes by building better models. You can see that over the last 10 years, we've almost doubled the accuracy, which is huge because that allows the ability to come up with better models and understand things better, allows us much better understanding of predictability and being able to manage that. The other thing I like about hurricane and the connection to Agile development is we can look at the model of uncertainty and look at it from an iterative perspective. I sort of see if I'm looking at this from a software project perspective, I'm out here, I don't know for sure where my market is, where I'm going to it. I have a general idea, but I don't know it specifically. I don't know if I'm going to hit down here towards the Mexican border or up here towards New Orleans at the beginning. But as I gather more information and iterate, I can refine that. I can pull more information in from my customers, and eventually I can figure out that's the market I really need to hit because that's the market that's useful and I'm going to serve. Let's look at other predictions, financial markets, for instance. This is a prediction that's looking at the Dow Jones average between 1920 to 1936. Nice quote here. Severe depression like that of 1920 to 1921 is outside the range of probability. This is from the Harvard Economic Society weekly letter, November 16th of 1929. And you can see the little dip down there in 1920 to 1921. And they're saying something as bad as that, even though it's already had an initial spike in the market, is outside the realm of possibility. And in fact, as we know, the stock market tanked. So experts are making predictions all the time. And we have to understand what the basis is and realize that it is tough to make predictions. War, this is a good quote I love. This is about the elephants in the room. I even brought in an elephant here. They couldn't hit an elephant at this distance. That was General John B. Sedgwick, the Union Army Civil War officer's last words uttered during the Battle of Spotsylvania in 1864. He didn't get to finish it, the sentence. Here's a nice view of, also from a war perspective. This is John Cleese of Monty Python fame giving a talk that I came across in it was done around 1989, 1990, sometime in there. And when I heard it back at that time, I thought, this is exactly what we're about in software as well. So let me just play this and we'll see how it goes. We're going to have to...
The guided missile sets off in pursuit of its target. It immediately sends out signals to discover if it's on course to hit that target. And the signals come back. No, you are not on course, so change it up a bit and slightly to the left. And Gordon changes course as instructed, and then rational little creature appears. He sends out another signal. Am I on course now? And back comes the answer, no. But if you adjust your present course a little bit further up, and a little bit further to the left, then you will be. So he adjusts his course again, and sends out another request for information. And back comes the answer, no, Gordon, you've still got it wrong. You must come down a bit and a foot to the right. And the guided missile needs rationality and persistence. He listens to us all. Goes on, making mistakes, and on, listening to the feedback, and on, correcting its behavior in the light of that feedback, until it blows up the nasty enemy thing. Then we applaud the missile for its skill. And then if some critic says, well, it made a lot of mistakes on the way, we reply, yes, but that didn't matter, did it? It got there in the end. All its mistakes were little ones in the sense that they could be immediately corrected. And as a result of making hundreds of mistakes, eventually, the missile succeeded in avoiding the one mistake which would really matter, missing the target.
And that's what it is in software development as well. Right? We make mistakes, but those mistakes are small. We iterate, we feedback, we inspect and adapt. And we bring things back to the end game, which is delighting the customer. To give an example from movies, the Titanic, up until Avatar, used to be the highest grossing film. And most movies aim to be the Titanic. Well, the reality is most hit movies end up like the Titanic. 78% of films lose money. 6% of films make 80% of the profits. A highly risky business. And this is one that's probably the movie, I think people are in this more for the allure of it and the fame than actually a lot of the, they could be much more profitable, I think, if they manage things a little bit differently. Another one, books, the book market. This is my book, Stand Back and Deliver. 300,000 books that were published in 2004, less than 25% sold more than 100 copies. Okay? These are industries that just make it, find a way to make it happen, and they just hope for the big bang that's going to matter. Poker, any poker players here? Recreational poker, not for money, ever. Well, all right. We'll put this test up. But anyway, in a game of Texas Hold'em, which of these three hands do you think is the strongest? Take a look. Couple seconds. How many pick A? Any picks for A? Couple, 2, 3. How many pick B? The pair. All right, quite a few. How many pick C? So only 6, 9. All right. So most people like that pair, that D. All right, what's our results? The survey said the answer is 29.6% chance of winning with that little pair. The A's are a little bit better, 33.5%. And the one that we don't expect at all, the 6, 9, actually comes in at 36.5%. Why is that? It's actually because the second card in the set is actually a lot stronger determination of what the strength of the hand. Most people tend to look at the strong card, the ace, or they look at a little pair. Reality is a 6, 9 in this case. Not that any of these hands are really good, but you think it's often deceiving as to where the real strength is. Let me take a look at another thing from poker. Let's look at percent of hands won. Do you think percent of hands won would be a good metric for poker's money success? How many think it's a good metric? Not a good metric? But actually it turns out to be a good metric of money lost. Right? The more hands you win, the more likely you are to lose money. Right? Why do you think that would be? Yeah. What's that? Focus on the hands you're going to win a lot? Yeah. If you're going to win a lot of hands, what do you have to do? You have to stay in on bad hands, right? Because you'll get lucky occasionally. Right? Most people that are good at poker know when they've got bad hands and they get out. Right? What's our management philosophy? Right? Make it happen no matter what, even if this thing's doomed. How many people, if you've been on a project, you know that anything's doomed from the start, but we just persevere and we go through a death march. And in fact, everyone dies, and the project dies, and we regret it. You got to get out when you don't have the hand to eat. Right? When the market is stacked against you, you got to get out. You got to learn that. Play the hands that are worth playing. Here's an example I like from the. It's not really from the medical world, but I could find one from someone who was playing a doctor on TV, and I really like this clip.
Do you want to continue talking about me, or should we discuss what the liver damage tells us? I was born in a log cabin in Illinois.
Hemolytic anemia doesn't cause liver damage. Add the fact he's coughing blood, you've got 3 of the indicators of organ-threatening lupus.
It's moving too fast. Could be hepatitis E. There's only been one case of Hep E originating in the U.S. since his history, since he's been in and out of the country 4 times in the last year.
You really think he's got Hep E?
No, I think lupus is way more likely.
All right, then let's start him on anti-cytoxin and plasmapheresis.
No, we should rule out Hep E. You just said it wasn't Hep E. You said lupus is way more likely, but if we treat for lupus and it is Hep E, then he's touched. Exactly.
But there isn't a treatment for hepatitis E. Either he'll get better on his own, or he'll continue to deteriorate.
Yeah, I went to medical school too. Started on Solumental.
If he's got Hep E, that's only going to make him worse.
Not as much. It's Goldilocks, people. Won't hurt him so much that it'll kill him. Don't want to hurt him so little that we can't tell. It'll hurt him That's right. And if it does nothing,
We'll know it's not hep B and can start treating for lupus.
now watch me do it while I'm drinking a glass of water. What do we tell the dad? We think your kid has lupus, so we're going to treat it from hepatitis B. And oh yeah, if it really is hep B, we're not actually giving him hep B medication. So it's going to make him worse, not better. Go for that.
So you want us to lie?
No. I want you to lie.
Why me?
Because he trusts you.
So some challenges there, right? We can go for what we think it is, but if you do that, you've got a problem, right? So that whole process that he's going through is one of analysis and trying to figure out, well, what options are out there? What information can I gather that's actually going to make me make a better decision? And then in the process, figuring out, the end game there of how do we deal with the politics of telling them what we're really going to do, because the rational person doesn't like to deal with uncertainty. They don't want to say, oh, we're going to hurt you just a little bit in order to make sure you're safe. But you have to develop that way to work with people so that you can actually deliver what they really want, which is to save the child. This whole piece comes together in a field that both Chris and I worked in, which is real options. And the idea of real options has developed as an area from the financial options perspective, options on stocks. But real options deal with not financial issues, but the rights and obligations, or the right without obligation to do something. One of the best examples, I think, of a real option is an airline ticket. Because an airline ticket, we think of an airline ticket as a ticket, as a thing. What it is really is a right to get a seat. But if I don't want to go on that plane, I don't have to. Right? So it's a right to do something. The airline has granted me that right. But in fact, it's really just my option to go or not go. This example here demonstrates two of the key principles, or just a reminder, two of the key principles that come from real options, is that there's a value to information. We saw it from the medical example. There's value to the information that we're collecting as we're going through the process. And there's a value to having flexibility, value to being able to say, given that this set of scenarios happens, I still have options that I can do some scenarios C or D. Real options provides that structure for doing it. And the piece that's quite useful is to say, given that I know that there's uncertainty, I know that I can create these options, and sometimes these options are just lying around, and they're sometimes available for free, sometimes I have to buy options. But if I can buy those options and have them, then I can use it to gather information, I can use it to build in flexibility that I can subsequently deliver on that flexibility. In the software world, as we're going through, these two issues show up all the time. As I can collect more information and dig down into what are the things I need to know in order to make some decision. I can frame that, and I can do those things early in order to buy that information. I can also delay decisions, which puts some of my flexibility, or I can build structures in such that if I have to make a decision in the future, I can build off that flexibility. So I don't have to limit myself, I don't have to lock myself in, because software has that type of flexibility, and I can structure around it. I was involved in running the Agile conference this year. So an Agile conference is another thing where there's a lot of uncertainty. Built running a conference. The team here has done a fantastic job of organizing this conference. The North America Agile Conference in Salt Lake City was celebrating the 10-year anniversary of the Agile Manifesto. We had 1,600 people. One of the things that we introduced this year was some Agile principles into the planning and the operation of it. We put 2 iterations into our review process. And what you can see from here, in this light blue line was 2002. When you have submissions, almost everyone waits until the last week in order to put their submissions in. I think 80% of the submissions end up coming in the last week. And we said, oh, if that's the case, what happens if we create 2 deadlines? And it turns out it works. We got half of it within the first iteration, and 80% came in that last week still. But what that did was it gave us an extra 5 operation and information. So we bought information, it also bought some time. So this is a case of delivering early, actually delivering value and delivering information. The other thing we did when we were trying to keep the key uncertainty value parameter when you're running a conference is number of attendees. So we built in structures to help us understand. This is a chart from 2010, the Agile conference in 2010. Anyone have any idea as to why we had this dip in 2010? Anyone attend the Agile 2010 conference? So you may not know, but the Agile, we were originally going to be in Memphis, or in Nashville, and Nashville flooded. And so we lost our venue. We frantically went into trying to create options right after that, and ended up in checking out Orlando and Las Vegas. Fortunately, we were able to change our venue to Orlando, and within a very short period of time came back up and had an excellent conference that Jim Newkirk ran. And so the thing is that what we're really trying to understand is, what is the bounding of the uncertainty? And we were able to predict it pretty well, ending up coming in last year around just under 1,400 people, pretty well within our bounds that we had established. So this idea of bounding and taking that information and then turning it into useful, that we can make decisions and operational decisions, quite important. Oil and gas exploration, this is my area. What do you think the percentage success rate is for oil exploration? Any takers, any ideas? Wildcat wells?
15.
15, what?
15%.
15%, okay, pretty good. Yeah. Anyone else? Yeah.
Different in different areas of the world.
Different in different areas of the world, but for the most part, wildcat wells they're pretty close. Turns out it's about 90 to 80%. 15, spot on. This guy knows something. Now the thing is 90 to 80%. If you use our software, it's more close to the 80%. We do a little bit better, but huge uncertainty. But oil companies are making a lot of money. How are they making their money if they're failing 90%, 80 to 90% of the time? Right?
Raising the price of gas.
Because when they make it, they make a lot. Right? It's worth a lot. So they don't go out and say, well, we're going to get mad because we drilled a dry hole. Right? They go, we're going to make sure we drill enough of them, and we balance our portfolio and use that risk to our advantage. Another thing that comes from oil and gas is something that's called geosteering. When we plan a well, right, we do our planning. Planning's a good thing. It's good to have planning. But we plan the well based on what we know. The thing is, when we're drilling, we collect some real-time information. We learn more. We have a guess as to what the reservoir looks like, where it's at. There's all sorts of science that we put in. And we do a pretty good job of knowing where things are at. But the thing is, we learn more every time we collect more data. So geosteering is about making sure that the well is where you want it to be, not where you planned it to be. Right? And that's the same thing. It's all real-time adjustment, real-time feedback. And that real-time feedback is really critical to adjusting when you have uncertainty. Another thing that we see in drilling is that drilling has been using Scrum-like principles for a long time. This chart here of depth versus days, they've used that as their baseline of managing their projects. They knew that Gantt charts and things like that didn't work. What really mattered was how far is the drill bit going down and how am I managing it over time. Very much like a burn down or burn up chart in Scrum. The other thing that the drillers do is they have a daily drilling meeting where they explore, well, what did we do yesterday and what are we going to do today? Right? So these basic concepts are around, and they just naturally migrated to that because of the type of business that they do. But be careful. Look at this sign. Caution, the sign has sharp edges. Do not touch the edges of this sign. And if you look in fine print, also the bridge is out ahead. Make sure you're paying attention to the right risk. One of the things that we do with the software that we developed is something that we call a tornado chart. And with a tornado chart, we try to understand and try to put some quantification around which risks are really important. So in this case, the huge uncertainty is around the size of the reserves. Oil and gas price is something that we don't have a lot of control over, but it has huge uncertainty. Some of the other things which we thought might have been an issue, our schedule, facilities cost, well count, or drilling costs, the cost issues are relatively small. It's all the value side that's particularly interesting. So what do we do about that? Once we know our uncertainty, we can make decisions and we can find out, do we need to get more information? Do we do something to find out more information about the reserve? Do we do something with gas price? Maybe we do some hedging of pricing. But if you quantify and bound for uncertainty, you can actually make the decisions about it. Same in software. We can understand where the uncertainties are, understand where the big issues are. We can make some of those decisions. This is an example maybe from software project. You know, the key thing is in many cases is whether the product that we're delivering is actually meeting, is going to be accepted by our customers. Schedule uncertainty might be an issue. General market uncertainty or cost uncertainty. If we look at this and have a discussion with the team, you can actually say, okay, now we have this. What's our risk tolerance? Are we totally risk avoidance? Do we want to try to get rid of all the negative? Right? Probably not a good idea to try to get rid of all the negative. Because what will happen is you get rid of all the negative, this is going to drop off drastically on the upside. Because every time you take an action to do something on one side, you're likely going to reduce the other side as well. So when we look at risk, this is the four categories that Chris and I came up with, is one's a delivery failure, business case failure, collateral damage, and then the last, political risk. So we're going to start here with the story of collateral damage. Collateral damage is when we deliver something, and what we deliver either puts lives at risk or has some quality issues that create business problems. This is the case of the London Ambulance Service. Anyone know the story of the London Ambulance Service? So the London Ambulance Service was rewriting their software system, I think about 10 years ago, and they went ahead and deployed the system for ambulance delivery. The result was they had terrible performance problems, terrible quality issues. It resulted in an 11-hour wait time for an ambulance, right? Horrendous when you're in a mission-critical, safety-critical issue of getting service. They estimate that they had about 20 to 30 deaths as a result of this. They had really not done any performance testing, they'd done no serious quality work, and it took them a long time in order to roll the system back. They had to roll the system back to the old system, and they had no real contingency plan for doing it, so it took them a long time to be able to do the rollback. When you've got collateral damage issues like that, when there's a potential for collateral damage, you've got to manage that risk differently. This is the case where the delivery risk resulted in collateral damage. The Denver airport is well written up in Walsey with Bears as an issue of the software for handling the luggage. That system was not available. It actually wasn't going to be. People on the project knew it was going to be a failure, and they had no backup plan for how to deal with it. They had no manual mechanism. The slots for handling the luggage were designed for automated carts, and you couldn't get a person to push them through. So they had no real backup plan. They delayed the whole opening. As a result of it, they delayed the whole opening of the airport because of the failure of the ability to handle luggage, which was blamed on software. It should have been, there's plenty of blame to go around, but software is one of the things that they blamed for it. The Ariane 5 rocket, again, this is the case where it was a units conversion problem, resulted in a blow up of the rocket. Just something that could have been caught within a more rigorous testing process and more better quality built in. And then lastly, come back to the oil and gas the story here. I'm beginning to think it wasn't such a good idea to turn off those unit tests. Remember that little accident that we had off the Gulf of Mexico, the condo incident? Pretty much what I've been able to gather from just reading the report on that incident was it was pretty much a failure to look at the tests that they've done. The testing environment that they do is they get a test, they do a test, and the test is not like a software test where we pretty much know it failed or it didn't fail. But they had a test, and they ran it twice. One time it failed, and the other time it gave them a nebulous result, and they said, well, that's good enough, and they moved on. And then we know what happened. Right? So it was actually really, I created this cartoon well before the Wakanda incident, but it pretty much describes exactly what happened in that incident. There was a failure to test, and a result of failure to test, humongous collateral damage, business damage, environmental damage, monumental disaster. So when you've got a situation where you have potential for collateral damage, the thing that you've got to make sure is that you build quality in, you build testing in. You've got to have quality that's manageable. And you've also, if you've got a situation where you're going to do a roll something out, think about, do you have an effective rollback strategy in case something comes up when you actually go into production? And also test it in the environment that production is going to have as much as possible. So, realize that you've got the risk, given that you've got the risk, do all the things you can potentially do to mitigate it. Next one I'll move on to is business case failure. This is the Iridium phones from the almost bankrupt Motorola back many years ago. Huge cell phones. Big problem, they were large, people didn't want them, and they didn't work inside buildings. And they spent all this money on satellites, did all these things. They didn't understand what their customers wanted, didn't understand the customers, went ahead and started delivering anyway. And you still actually can get an Iridium phone, but they had very special purpose and nowhere near the fit for purpose of what they've invested in. Got stories from new product development. I've got a quote here from, I think there's a world market for about 5 computers from Tom Watson. And somebody, I think everyone's got 5 computers at least, it seems like now. So a little bit underpredicted there. This is a report from the Standish Commission on features and functions that are developed in software projects. And what they reported back was that 64% of features that are put into the system are rarely or never used. And you have to be a little bit cautious with that because something like an install is rarely used, but it's pretty important to be able to do the install. So I'm not sure of the exact part, but certainly the fact that there's a lot of potential for waste there if 45% of functionality is really never used. So that brings us to, well, how do we know, what's a good model for what to figure out what we should be building? How do we connect our customers? So powerful questions are, what are we building? What business are we in? Too often we get people that are more asking, well, what building are we in? This model that I like to use is one by Neil Nicolaisen, one of my book partners. It's called the Purpose Alignment Model. And what we look at in order to help us understand really what our customers and how we as an organization are going to meet that and make advantage of that is we look at, well, what is our set of market differentiation ranging from high to low, and how mission critical is it that we are the ones that deliver it? So if we're looking at something that's low market mission criticality and low market differentiating, that's who cares, right? Who cares if we're not market differentiating and we're doing the same thing because we don't have to do it? There's a lot of things which are still mission critical. They're high mission critical, but they don't differentiate us in the market. Those things we just want to get as good as our competition or as good as the leading company in that space. Look at the market leader in that space and just get as good as that. It's also a place where we look, well, what can we buy off the shelf that's parity, and then make use of that. We don't have to be any better than that because anything that we're better than that is waste. It's not going to differentiate us in the marketplace. So parity is the aim for that. The key one here is the ones that we're actually going to deliver differentiation in the marketplace. Our customers want it, and we believe it's mission critical that we are the ones that deliver that to the market. So that's really where we want to emphasize our intellectual capital. There's another angle there, which I don't really like his label of partner, but it's one where it's mission critical. It's not mission critical that we're involved, is that we own it, but it is something that we believe can create market differentiation. And I would really call that strategic partner. It's something where we're creating and differentiating our overall product line, our overall offering is differentiated, but we don't have to be the ones that own it. And I'll get to an example of that in just a little bit here. So if we look at this in practice, is the things that are who cares, we want to minimize, eliminate. Things that are parity, we want to achieve and maintain parity. We want to mimic, we want to simplify. Keep it as simple because anything more than that's gold-plated. We want to focus on innovation and creation in the place where we've got market differentiating. And then in the case of partnership, is there a place where we can create a differentiated partnership? What I like about this model is that it's applicable at a lot of different levels. It's applicable at corporate strategy level. It's applicable at the product strategy level. product and project level. This is one view of looking at Apple. Apple's done very well. And if we can look, and I think they map pretty well into this model, the places where they're really focused on differentiating things like new product design, user experience, and in content distribution with things like iTunes. What did they go with parity? Well, they made a partnership with Microsoft to get Microsoft Office on the Macs. They switched over to Intel hardware to be, again, at parity when they were previously on Motorola chips. And other areas of software that just said, well, we'll just let the market pick that up. They pretty much got out of the peripheral space. They do very little in that space. And then in the iPhone, they created a strategic partnership with AT&T. They didn't have to build a whole network, but they realized that if we make a monopoly, sort of like a monopoly, I can't call it monopoly, but we say there's only one provider, and up until recently, AT&T in the US was the only provider that you could get an iPhone. That's now opened up to other providers, but they were able to make it for a long time. Market differentiation, and they made that strategic partnership. One thing about market differentiation is over time, market differentiation becomes parity. So now that they're saying, okay, now it's parity, we'll go ahead and sign up other networks and take advantage of that because they could do that. Move on to a fun topic here, political risk, a different one that always one to struggle with. But political risk fundamentally is about change or maintain, right? Politics is I'm either going to gain something from a change or I'm going to gain something from maintaining what I have. And so what I look at, and this is again something a book from Neil Nicolason did a nice survey of his CIOs and said, well, where are my risk points? Where do you think the biggest risk? If we look at this here, we got you sitting out here, you get direct reports, and then your boss above. You got bosses, peers, and peers reports, and then people that are more indirect. Where do you think the biggest political challenges show up? I think what we find is peers and bosses' peers are the places where they're most likely to be ones that have something that either they'd like to maintain what they're doing now and you're putting a threat to that, or they'd like to create their own change in some fashion. So those are the ones you need to manage and work with. Really, the only real advice on this part that I can offer is this is all about networking. Managing political risk is all about networking and making contacts and really asking these two questions. What's in it for them, or what's in it for them to have everyone succeed, right? If everyone succeeds, do they also succeed? If that's a possibility, that's what you really want to sell them on. And then the other question is, what do they worry about losing if you're successful? And you can't necessarily ask them this directly, but what you can work through this, and it's about building relationships, building networks, and trying to see what you can do to get those two questions dealt with. Because if you can understand where they're coming from, where it's their motivation, that's what will drive the ability to manage that political risk. Now here's a nice example of one form of management challenges, long ago and far away.
The Emperor is not as forgiving as I am.
projects like that? So one of the things that I also look at from political risk is one of, we really like to collaborate, and sometimes we've got collaboration with people that don't necessarily want to collaborate, or we cast them out as being non-collaborators. And this is a model I developed recently after working through with collaborating with people on a book and looking at collaboration, and realized that there's actually an issue. A lot of times what we call people that are non-collaborators are really more likely people that don't agree with us. So I sort of created this model of those people that agree with us and collaborate with us are collegial. They're sort of our friends, right? The ones that agree with us, but we don't really call them collaborators, they're in sort of compliance mode. They're just sort of going along with things, but they're not causing us any trouble. They don't look like they're trouble. The ones that are disagreeing with us and not collaborating, they're what I call combative. They're causing us trouble. And then this last category is sort of an interesting one, where they disagree with us, but they're actually collaborating with us in some fashion. And that's really the cool part, because that's when you get some nice creative tension. What I'm going to look at particularly, I think this is the one where we worry about the most, because this one is often we don't really, when we have this, it's great, but often we don't even think about that one. This is the one that really causes us trouble. And what I find too often is what we try to do in common practice is bring the combat, we try to appease them and bring them into compliance mode. Right? And what I have found much more useful, and there's a couple of ideas, a couple of things that you can do to make this work. It's much more useful to leverage the fact that they're disagreeing and bring them up into the collaboration space. Find a way to work with them. And the key thing that I find there is about bringing things to drive towards purpose. Right? If you can align yourself on common purpose, and the difference in the disagreement is not around purpose, then you've got an opportunity. If the disagreement is over purpose, you've got to work that through. But if the disagreement is over a solution space, how to do something, and not over the purpose, then getting back to purpose is a great way to bring it. And actually what happens is that disagreement creates that creative tension, and you actually get together in a collaborative environment, drive towards purpose, and realize that both of you have useful things to offer, and collectively you end up with something that's even better. And the lack of having some of that creative tension ends up too often having a groupthink. And you have wonderful examples of companies that hired people that were pretty much the same as them. Ken Moore at Digital Equipment is a good example of that. He hired a lot of people, great guy, brilliant, hired a lot of more brilliant people, but they thought almost just like him. And he ended up, I guess they ended up selling back to Compaq, which ended up being bought by HP. So companies like that, or you get into that environment and you don't create enough disagreement, you can end up with too much groupthink, and you can be real problematic. So this is my last one on politics. Is an example of I thought this is a fun example of Agile leadership.
Stay
here. We'll take care of this.
I have decided that we shall stay here.
So the politics there, you see the self-organizing team get going, and the most important part is you make it, it's made him think it was his idea to do that. The key part of politics is making it somebody else's idea. Give it them credit for taking the idea that you want to have happen. So it's something challenging. So lastly, close down here with a bit on delivery failures. The one we end up spending the most time on because we just love to get into our challenges of delivering software issues. We have lots of delivery challenges. This is a report from the Standish group saying that only 35% of projects are actually successful by their definition of delivering based on their original expectations. 19% fail outright and 46% challenge. So there's some questions about the actual how they're making their definitions. But in general, we know people's expectation or the realization and the perception in the market is we have real serious challenges delivering. This is what my sort of story of what some typical software projects end up looking like. We have the project kickoff. Dorothy says, "When will we get the requirements?" Just give me your estimates by this afternoon. The team binds together. No, we need something today. Okay, then it'll take 2 years. No, we need it sooner. I already promised the customer it'll be out in 6 months.
You're a very bad man.
We're not in Kansas anymore, the developer hero says. And they just about got things under control when we have a reorg.
My, people come and go so quickly here.
And then they get into the testing and
Going so soon, I would hear of it. Why, my little party's just beginning.
And we try to avoid that in Agile development by bringing testing up front and keeping going. But I mean, too many projects actually look just like this one. This is we're going to go into now some numbers that came from a lot of the metrics that we were keeping at Landmark. I wrote a paper called Software or Schedule Estimation and Uncertainty Surrounding the Covenant of Uncertainty. So I'm going to go through a little bit. What I found when I was looking at the data that we had from back in the late 1990s and early 2000s, looking at estimates of initial estimate, accuracy of initial estimate. So if I look at the initial estimate on the bottom plotted against the actual, this purple line would be an ideal state where actual is equal to initial estimate. And what I found was it scattered all over the place. Mostly, not surprisingly, our actuals were quite a bit higher than the initial estimate. So I looked at this scatter and I said, I actually seen something almost identical to this when I looked at a book from Tom and Marco called Controlling Software Projects, and he reported less data, but almost exact same scatter. In fact, here it is showing up in the red triangles. And so the scatter here is almost identical. I said, there must be something here about software project estimation. Let's see what we can do. We can go a little bit further with it, take this data. And what I did is I plotted a cumulative distribution map. And what that shows is, as a percentage of projects, what percentage of projects were actually meeting a time that was less than or equal, less than the 1-to-1 ratio at this point here at the 50% mark, and what was it at 90% of the projects, what were they better than? And what we found was in between both cases here, about 10 to 20% of the time were we actually being able to deliver on the initial estimate, which is about what Standish would have been reporting around that same time as well. And a medium project was running at about 1.7 times our initial estimate. And if I really wanted to get to the point where I had 90% confidence, or 90% of the projects covered, I had to get upwards of 3 to 4 times what the initial estimate was. But what I found was that this pattern has been showing up in the software industry all the time. This is not something new. This has been showing up. It's just how I reported it has been a little bit different. I was able to pull together a lot of different. And that's the reality of what we face at the beginning of a project. We're looking at something on the order of a range of uncertainty of 1 to 4 times what our initial estimate is. We can get better at that. You can get a little bit better at it. But that's sort of the innate nature of the uncertainty that you're struggling with at the beginning of the project. You know, the other question I asked was, does estimation accuracy actually improve over time? This is the uncertainty cone that was published by Barry Bain. And it looked at, well, this is sort of the bound. And you can see here, this 2 to 1/2, that's sort of the point at which I was looking at. So that was showing up again. It was a confirmation that this type of behavior is seen. I wanted to see, well, do we actually get that type of behavior? And so I plotted up our data. A couple things showed up. One is, well, we were highly biased above the line. We were an aggressive software product company, so we were trying to set aggressive targets. I think a lot of companies are in that mode where they're biased towards the underestimation side. And in fact, it does sort of caper off into a uncertainty, into a code. But what I wanted to know really was, this is based, what really matters is how much uncertainty, I'm making a prediction going forward, how much uncertainty do I have in what's remaining? And so I had to plot that a little differently. I want to know, is uncertainty really reduced? If you take away an ordinary person's illusions, then you take away the happiness at the same time. I was worried about that. But the reality is that the remaining uncertainty is almost constant. It's almost constant with that 4-to-1 ratio. This band is much more like a pipe than a cone if you look at remaining uncertainty. The cone shows, well, what you're finding is the cone is saying what you would expect anyway, which is what I already know I know. So the uncertainty associated with that's not any different. But I haven't really drastically reduced my uncertainty. What I've done is I've bounded it by the fact that I now know something. What I still have remaining is also has uncertainty associated with it. So that's a key thing, is you have to know that making forward predictions based on what's left, there is still that uncertainty. If you get better at it, we are able to get better at it within our organization, but you have to still start with what you know and work on it. Agile, we were not using Agile techniques at this time. Agile does give you better, but burn down charts and velocity does give you better understanding of the ability to make predictions. A key build on this was a paper written by Lam Cao, Estimating Agile Software Project Effort, an empirical study. And the key part was with her study was that she did a similar thing, but just on one project, and worked at the task level and looked at the uncertainty associated with bugs and features. And we know features are just dressed up bugs of some sort. But I thought the key interesting finding from this was that the uncertainty associated with predicting bugs, the time to take to fix bugs, was twice the uncertainty of a feature. So what does that mean? Well, that means that if your testing's all at the end, if you're finding all your bugs at the end, you've thrown all your uncertainty at the end of the project. Right? That's exactly the opposite of what you want. It's the reason you need to build testability into the software. You need to be reducing your technical debt, doing a sale for Gerard, all the things you need to do to be able to ship so that you don't have a lot of bugs. This was an Agile project, and this is actually some more details. But you see these uncertainty bars around the bugs, which were, they were working bugs and they were finding them along the way. But because they had them, it made their end of the tail much longer. So they found that at the end of the project, she basically reproduced the same results I had in terms of the shape of the curve and the uncertainty. So one thing that I bring, that I've looked at as a mechanism for working with this risk is the fact that we've got to understand context. And one size does not fit all. That was one of the elephants that we had in the room, was that context is underutilized. I find context a good way to look at risk issues as well. And what I've developed here is the context leadership model, where we're looking at issues associated with uncertainty. Uncertainty, one of the big issues that brings risk, as well as another part being project complexity. And what we have within those low uncertainty projects, low uncertainty projects and low complexity projects, I call those the sheepdogs. And they sort of work in, they're small, they're well behaved. You don't have to do a lot to manage those because they're not huge uncertainty issues, they're not hugely complex. You don't have to put a lot of overhead around those. Moving up the chain, we go into the cults, which are simple young projects. These need agility, they need tight teams. These are the great examples of co-located agile teams with a dedicated product owner that's really focused on working tightly because you want to deal with and get that uncertainty, and it's not particularly complex. It's a good place where new project starts. Down in this corner, we've got the complex mature market. They're very, these are oftentimes the cash cows in the market, and you need to be able to manage this. The management of the complexity is really about the size of the team and the interfaces and the dependencies and managing those issues. And in the upper corner here, we've got the really complicated ones, which is complex and uncertain, the bulls. You need agility to handle the uncertainty, but you also need some process definition, and you need really strong leadership in order to be able to cope with complexity. And one of the things we find is this is where your real challenges of leadership are. These are the best leaders need to be able to be focused on these projects. And your organization probably doesn't have many of them. What I found is that a lot of organizations have leaders which will go this direction, and we have leaders which will go this direction. There's only a few that are able to pull that both together and be able to manage those really complex and uncertain projects. And sometimes what you have to do in order to develop that is you take some of these leaders and put them into projects over here and see if they can even cope with the switch around in order to get that experience. So here's a bull product release. We can get this wonderful Spanish vista. Any resemblance to Microsoft is totally coincidental. not intended. So what I look at here is I look at the set of characteristics, and something like uncertainty, look at market uncertainty, technical uncertainty, number of customers, duration, and change. And I look at this perspective of sort of trying to come up with some approximate score here, simple score. And part of the reason for doing this as well with complexity, team size, mission criticality, safety criticality, team location, team maturity, you have domain gaps and dependencies that you're working on. To look at, is there anything that you're taking on here that you could change in order to, if you can reduce either uncertainty or reduce complexity, you have in effect reduced risk. So this helps as a mechanism to say, here's where I'm at to start with. Can I do anything about it? Like, for instance, reducing uncertainty. Could I use proven technologies instead? If I've got so much market uncertainty, should I be using proven technologies in order rather than taking on risk both on the market side as well as the technical side? Could I reduce the project duration or get out and do more frequent deliveries? On the complexity side, can I co-locate the team? Is that a possibility or is it just not? Could I break the project up into sub-projects? If I break the project up into sub-projects, it gives me a mechanism by which I can manage the interfaces more and put some of the key people that know how to do that on that management of the interfaces. For one example here, partitioning. This is an example of a Swiss stock exchange that Pollyanna Pixton ran, where overall the program, she was the program manager and managed it as a full program, but we had there was a legacy system on it which was managed as a dog. Pretty much didn't have to deal with that too much. The cash cow was the server side, which was a big project, but pretty well maintained, not a huge uncertainty. And the cold project was the front end, what the trading terminals looked like. And that was the one that really had to be frequent iterations and done in a particularly strong, agile way. By breaking the project up in this way and managing the interfaces, we're looking for the type of things, same things we're looking for in software development, loose coupling and strong cohesion. Get your teams together, put your team boundaries in places where they're strongly coupled, or they're strongly cohesive in what they're working on, and manage the interfaces through loose coupling mechanisms. So one of the things I tie this together with is something that actually looks very similar to the Neil-Nicholas model, the purpose alignment with market differentiation and mission criticality. But it's actually a different model. It's one from Dealing with Darwin by Geoffrey Moore. And he was looking at a very similar issue of if you've got something that's not mission critical now, but it's market differentiating, your mode of operation is one of invention. You then move into where it is both market differentiating and mission critical and start deploying. Eventually it's no longer mission critical and it moves into a managed mode. And eventually it's no longer mission critical, so you try to offload it. This is his base model. To that, I think what I've built on top of that then is a key element of what you're doing relative to change. So you're starting in the invent mode, you're trying to create change. You're trying to force change in some fashion because you want to build something new. Once you're into the deployment model, you're sort of in the Agile sweet spot of embracing change. Eventually, as you're managing it, you're more into a control change mode because you're trying to get to a parity model. And then eventually you're trying to eliminate change. You're trying to do the least amount possible in order to, eventually you'd like to offload. And from a development structure model, this is the ad hoc sort of 2 men in a garage are trying to do research. It's not, in their teams to try to do research in a natural way, and I think you can do it. But I think it's actually, sometimes it can get in the way, and really a 2 men in a garage is a great way to get something kicked off and going. And it's with that, as it gets more into the mission criticality stage, that's really a great sweet spot for Agile. Eventually we get a little bit more structured as we move down into the control change mode. And not to say you're not Agile down in the structure mode, it's just that you're more structured than trying to embrace change. You're trying to control your change as well as do your Agile iterations. And eventually you're getting to a mode of offloading or outsourcing. The other part here of this, back to the context model of uncertainty and complexity, is you can look at it from a portfolio perspective scattered around. And the key part here is you don't want more projects in this bold quadrant than you have people that are able to manage and lead those projects. Because if you put somebody who can't lead that project, they'll get thrown off the pole. It's pretty, we've seen it happen, and it's pretty predictable. There's only a few people in any organization, top people who really are able to lead those projects. Now, don't over stereotype. Not all dogs are the same.
Hey, nice dog. Yeah, this is Viper, your red border collie. Watch this. Viper, fetch. Good boy, Viper, you're such a smart dog. So, what can your dog do? Fergus? Bud Light.
So we have good dog, we have good dog, and we have bad dog. We have both dogs. Both got the job done. They use different ways to get the job done, but they both got the job done. So that's the thing we learned from that one. So now we take it to the next level here of, well, how does politics and schedule estimation come together? I love this quote from Steve McConnell. Developers tend to be temperamentally opposed to the use of negotiating tricks. Such tricks offend their sense of technical accuracy and fair play. Developers don't want to offer lopsidedly high initial estimates, even when they know that customers, marketers, and bosses will start with lopsidedly low bargaining positions. So there's a political game going on with that as well. This is one such example of that.
We want this and that. We demand a share in that and most of that, some of this and all of that. Less of that and more of this and plenty of this. Another thing, we want it now. I want it yesterday. I want more tomorrow. And the demands will all be changed then, so stay awake.
So yeah, and it's difficult to get a man to understand something which his salary depends upon his not understanding it. So those political games go on. What I wanted to drive into next is sort of this element of bias. And a nice IEEE software article by Jørgensen from Syntef in Norway. He did a study where they had 4 different estimation teams, and they were all given the exact same spec to work from. And the only difference was in each of the teams. The first team was given, said, here's the spec, give us an estimate, and we think it may be about 800 hours. The second team said, here's the spec, and we think it's about 40 hours. The last team said, here's the spec, and we think it's about 4 hours. And then the very last team, here's the spec, and we're not going to, they didn't give them any guidance. So what do you think the estimation teams came back with for this top one?
846.
Initially 800, what do you think? What?
More?
More? Maybe more? Well, what came back, so the first one, they said, you're smoking something. It's not 800 hours, but it's more like 300. We'll start with the first one. The team that wasn't given any guidance, they came back with 160, right? So, but they said, yeah, it's, no way it's 800, but they came up and said 300. The team that said 40, no, there's no way it's 40. 100 is more realistic. And the one that this one at 4, they still said, no, we think we can do it in 60. So this initial guidance and bias for this exact same spec, right? So here we have an example of the same estimation happening, but just this trivial bias that's been given based on an initial. And one of the things is, you know, if they, based on you are reading something into the fact that you're saying, I want a really good product if you're going to give me 800, whereas if I'm only going to get 4 hours, you know, I want the quickest thing possible. So it is possible that maybe you can interpret the spec and do something quicker. But this bias shows up all the time. They did some other studies that showed different types of bias, just changing a few words made huge differences in how the estimators came back with things. So you have to be really careful. Estimation is a tough challenge, especially when it comes to making predictions. When we understand bias, what gets us into trouble is not so much what we don't know, it's what we know for sure that just ain't so. You think about this task A, create a 6-sided random number generator, something like a dice-like thingy. Every member of the team needs to roll a double 6. Did you have to make a dice-like thingy? The simplest answer would have been for the 6-sided figure, 6-sided random number, this pencil happens to have exactly 6 sides. Each of you should have been able to get a pencil. You could make a 6-sided random number generator. We messed around by saying it looked like had to be a dice-like thing. With saying a lot of people were making dice, of course. We didn't say the randomness had to be uniformly random. The easy end, it has to be random, right? So you can't have a double 6 on every side, but you could have a double 6 on 5 of the sides, and one side could have could be something else, and that would be a random number. So when Chris messed around this with some teenagers, that was exactly what they did. They figured this out in no time. But we're so want to do things right. We've been beat up in so many ways. We wanted to actually make a dice-like thing. So this bias in understanding this is a huge challenge. So with breakdown uncertainty, we have the things that we know for sure, the things that we know that we don't know. There are some things we know for sure. Then there are a whole bunch of things we don't know that we don't know, and this other category that we don't know that we might even know them, but we just haven't discovered it. The other thing I like to look at from this things that we don't know, some of these things are knowable ultimately if we put more energy into it. Some of the things are fundamentally unknowable. We could spend all our money and all our time trying to get in it, and we're still not able to get to the known state. What I look at and see this is, if all we do is work with the known knowns, that's sort of in the wishful thinking mode. If we're starting to look at the known, we're primarily into the discoverable risks, and when we're down and actually managing and understanding the bigger picture, that's when we're starting to get into overall uncertainty management. And from our mapping perspective, what I find is if all you do is work with what you know already, that gives you about a 10% chance of hitting that wishful thinking mode. If all you did was discoverable risk, you're probably at about a P50, 50% of chance of making it. And if you're actually down into uncertainty management and working a comprehensive picture, you're now actually possibly bringing it up to the 90% category. So I'll leave you with risk management is really about expectation management. A couple of things, it's about not having no surprises. Leaders and business people don't like, customers don't like having surprises. So if you work with them and you work with understanding what the expectations are, you can actually make some really good inroads. Some things that I have done, some proactive things that I've done, is take a look at pulling some risk issues in at the iteration reviews and the retrospectives. This particular one is one you just look at any time a promise has been made. No. For this project, what promises have been made, whom were they made, and who made them? Right? A lot of teams don't even know this. You've got to know this. You've got to know what promises are out because this is what the expectations that have been set. You've got to know that expectation so that you can manage that expectation. Next thing, this is the forward-looking part of the retrospective looking backwards, the forward-looking part of things. What key decisions and commitments might we need to make within the next 2 iterations? Right? That gives you an opportunity, if you're going to be having to make commitments, that you can start saying, well, if I've got to make that commitment, what information do I need in order to make that commitment? This is one that I've worked with a team and it worked really well. And I found that doing it anonymously was probably the best answer. That's what I would recommend. Basically asking the question, when will we be ready to ship? Will we be able to keep our promises? Is the team healthy and operating effectively? And is the team on the right path? When I did this particular one with the will we be ready to ship, this is the example, this is what I came up with, was as a percentage of people, so to each person I added the more frequent, each point here is one more person's perspective on it. And interesting clustering, all the developers were optimistic, said, oh, no problem, we're going to be ready to ship about what we said we were going to be. All the testers were a little bit more pessimistic. They said, well, no, it's not quite ready to get out there. And then the test manager said, no, I'm on the hook for this. So well, what was good about this is you can make this gives you an understanding of what's the team thinking about. And you can actually, as it turned out, we almost hit about the midpoint of this was actually what was able to be delivered on pretty nicely. So you get that bounding, and you can ask periodically. I like to do this anonymously because that way you don't have anybody trying to force one person or another a certain way, and you get the information out. You can get better, as I said, just like with hurricane predicting, you can get better through better models. Within our organization, this is plotting the estimation quality factor. Estimation quality factor is a number that is an indicator of how good your estimation is, published by Tom DeMarco and Tim Lister. And it's basically the inverse of your error. So if your quality factor is about 4, your overall aggregate accuracy is about 25% off. The industry average is just under 4, about 3.8. At the time I was doing the first study, we were just above, I think we were about 4.8. So we were actually better than the industry average, even with as scattered as we were. We were really pretty good about updating those. So that was coming up with refinements. Over time, we've been able to get more up into the 8 category, which is actually best in class. This estimation quality of 8. The overall aggregate error of around 12% with category 8. So you can actually get better if you focus on it, if you do some things. But you do have to ask the question, is estimation accuracy what you really care about? Are you worried about the sharp edges, which is your schedule, or should you be worried about the bridge out ahead, which is maybe your customer and satisfying your customer? One good example of this with wrong priorities, this was the Ford Taurus. The first release of the Ford Taurus in 1986. One of the most successful car launches in recent history. Certainly almost probably guaranteed that Ford saved Ford from bankruptcy back at that time. And the project manager said, we do a lot of customer interaction groups. We're going to make sure that we deal with customers. We're going to understand their needs. And we're actually going to act on those. And we're going to build better quality. We're going to make sure the quality is really good. And overall, fantastic product release. Only one problem. It was 6 months late. What do you think happened to the project manager?
Fired.
Fired. Right? Humongous financial success for Ford as a result of a project manager that was focused on what really mattered, which was the customer need, delivered late, made great money for Ford, but ended up being sacrificed. So what do you think happened? The second rev of the Ford Taurus around 1990, what do you think the project manager did then? What was the one thing they were going to guarantee they did?
Give on time.
Ship on time, right? They learned. How well do you think the second rev of the Ford Taurus did with the customers?
Not that
Much flatter. Nowhere near as successful with the second rev. Didn't respond to customers. Didn't really focus on the customer. You've got to really understand where your value proposition is coming from. Make sure you're working on the right areas. Typically, my perspective is work on the customer, and the other part is focus on the customer side, and the other part is much less of an issue. So one more closing here.
Why? Because I lie to a patient. I take risks. Sometimes patients die. But not taking risks causes more patients to die. So I guess my biggest problem is I'm cursed with the ability to do the math.
Yeah, so risk management is not risk aversion. Risk management is about understanding risks and taking those risks, because taking those risks is what actually brings value to the business. Too often when we get into risk aversion is a form of risk management, right? Taking no risk is a way to manage it. It's just not a very effective one for most businesses. So I was going to end with the elephants in the room. I was able to be a part of that discussion. It was one of those fun discussions I had, having a number of people at Snowbird and going through the different elephants in the room. And we had the Agile Alliance being our first elephant. Here's my elephant scorecard for today. I put little elephants in here. Talk a little bit about context. Context getting in the way of dogma. I created my own dogma around context, I think. Didn't give me anything for hypocrisy, but probably somewhere in there I was hypocritical about something. Politics, the Agile Alliance talked about the conference a little bit. Business value and product ownership. Managers are bad. Culture's a big one. We've got to understand that. Self-organizing teams and scaling. There's lots of these elephants out there, and the thing is, you just realize that the whole element of agility is a mindset about doing the right thing. Get your teams focused on the customer, focused on purpose, and all the specific practices are there to enable that, not vice versa. Lastly, my contact information, email up there, my website. I have not put this presentation on the website, but I will do so. So probably have it up there this evening, and post all my publications and presentations out there. ExcelNova.com is also the book partnership. Pollyanna Pixton and Neil Nicholas post a lot of their work up on that. And then Chris Matt's contact information as well. Feel free to contact me anytime about anything. Enjoy hearing from people's stories that they